So we have this problem 1945 of Leetcode, sum of digit of a string after convert. Now the problem states that given an string s consisting of lowercase English alphabet and an integer k, first convert s into integer by replacing each letter with the position of the alphabet. So if we have an lowercase English alphabet as ABC, we will convert it, this is string, right? We will convert it into equivalent one index numeric, right? So A will be converted into 1, B will be converted into 2, and C will be to 3. So we need to convert lowercase English alphabet to numeric value inside the string, and then the transform of the integer by replacing it with sum of its digits, and repeat the transformation operation k times in total. Let's take an example. Key we have this s as zbax, right? And zbax is the string that we are given. Now what is the first step that we are doing? First step is converting this string into its equivalent numeric value inside the string, right? So z will be 26, b will be 2, a will be 1, and x will be 24. Now this is the number that we have, but not in integer but in string, right? This is the first step. The second step is you need to perform the transformation operation k times. K is the value of k is given 2. Now what does transform mean? In every single transform, let's say we perform the first transform, we need to add all the digits of the number inside the string and make it the new string, right? And put it into the same string. Let's say what we have to do is we have to assign to s the sum of 2 plus 6 plus 2 plus 1 plus 2 plus 4, which is 17, right? Now 17 is the new number that we have. We put it into s. This is transform 1. They have given us to perform the transformation 2 times, so we'll perform the transform 1 another time. So our new s is 17. So 1 plus 7 will be 8, and this is our new transform. We perform the transformation 2 times over this s string. Now this will be our answer, right? Now there is a clever observation that you can think of, like the k value. If you see, the k value can go from 1 to 10, right? So they may ask you, they may give you this question and they tell you to perform the transformation, let's say 10 times. Now if you run a loop 10 times without even checking key what you have into the s string, then there will be a time complexity problem, right? Let's say we perform the third transformation. What do we have in s? 8. Now some of the digits of 8 will also be 8. Even if we go further, we perform the fourth transformation, we still have 8. So it will still be 8 no matter how many transformation we perform. If the length of the string, the clever observation is that if the length of the string is 1, no matter how many transformation you perform, it will still be the same. So at this moment we will break. No matter if we have the k value to be greater than 2, we will break from here, and this will be our answer. Now let's write the code for it. What is the first thing that we're converting? We are given a string s and integer k. K is for transform, s is the string that we're given. The first thing that we need to convert is from string to integer, right? Now converting from string to integer will simply iterate over the string. For let's say auto, we are iterating over string s, right? Now you could have done I is equals to 0, I less than s dot size I plus plus. It's fine. We are writing it this way. You could have wrote it in int I is equals to 0, I less than s dot size I plus plus. Both are same, right? You could have done this. I'm doing it this way. Now what is the first thing that we need? First thing, let's write the string, right? zbax. Let's say abcd is the string, right? abcd is the string that we are given. Now the first alphabet that we have is a, right? What we will do is we will take this alphabet. We'll taking this alphabet simply means writing it is pointing to here, so it is the alphabet. We'll subtract this from a. What do we have now? A minus a is 0. So we don't need to put this in 0 base. We need to put this into 1 base indexing. So we'll add 1 to it. Now this is the integer value that we have, it minus a plus 1. So we need to convert it into string. So there is a function in C++ called as toString. String. What toString does is that it converts integer into equivalent string and adds it to the string. If you, all we have to do is, now we have converted 1 from this to this, right? We converted 1 to string. Now all we have to do is we have to define a result. Let's say result is a string. We define it an empty string and put it into result, result plus equals to this statement. This converts ABCD into equivalent 1 2 3 4, right? And it is still the string. Now this is the for statement that we had. Now after that, after converting ABCD into 1 2 3 4, what we have to do, we have to perform the transformation. How many times? Transformation k times. So we'll run a while loop, while k minus minus, right? And we have to, well, I will talk about the other one condition that we wrote, the length of the string needs to be 1, right? If the length of the string is 1, no matter how many transformation next you perform, it will still be the same, right? I'll talk about this condition after that. Let's say we need to perform transformation k equals to 2 two times. So first we will have while 2, then we'll have while 1, and then we'll have while 0, which will break, right? This will not run. We'll have 2 times. So we'll wrote while k minus minus, and now we will perform the transformation operation. Now we had the result string initially to ABCD. We perform this operation, key converting it into 1 2 3 4 string. Now in transformation, what we will do is that we have this 1 2 3 4 string. We will, in the first transformation, we will add all these elements 1 plus 2 plus 3 plus 4, and it will give 10, and put this 10 again into result. For the second transformation, what we will do is that we'll add 1 plus 0 and put again into result. It will be 1, right? So this will be our answer after performing k equals to 2 transformation. Now there is a clever observation key. Even if you perform after any k number of transformation, after x transformation, it will still be 1. So when we have there is a crucial condition that we need to keep in mind. When we have the length of the result was 1 2 3 4, right? 4. When we have the length of the result to be 1, no matter how many transformation you perform, it will still be the same, right? So we'll add another extra condition to improve the time complexity, is that if by any time you have result dot size greater than 1, perform this operation, it's fine. If it becomes 1, right? If result dot size is greater than 1, if it's greater than 1, then go into the while loop. If it becomes 1, then you don't have to get into while loop, you will exit, right? So I put it into an AND operation. Now inside this, what we will do is that we'll define a sum for summing of 1 plus 2 plus 3 plus 4, right? So we'll define a sum variable and set it to 0. Now we'll iterate over the result string. For auto, we iterate over result, result, and what we do is that we convert all these 1 string, 2 string, 3 string, and 4 string. Like we will do, we have this as it, right? Now we will subtract this from 0. So we'll have 1 as integer. Similarly, we have this, we'll subtract this from 0, we'll have 2 as integer. We had 3, we'll subtract this from 0, we'll have 3 as integer. So we will do is it will point to each element minus 0 will give us the integer equivalent, and we have this in integer format. Now we will add it into the sum variable that we have created, right? Sum plus equals to this integer value. So initially we'll have 1, then we'll add 2, then we'll add 3 and add 4. When we had an integer value 10. Now what is the next step that we have to do after calculating sum? We have to put this sum integer value, convert it into string, and put it into result. So our result is no longer 1 2 3 4. Our result is now 10. and perform this operation k times. So this will be our solution, right? Initially, if you look at, initially we'll convert the alphanumeric to numeric value, then we'll perform the transformation k times, keeping an additional condition to improve the time complexity. Now at the end, what we are going to have, initially we had a result as 1 2 3 4, right? Then we convert it into 1 0, then we convert it into 1, and this is our answer. This is our final answer after two transformation. Now the question asks us to return the integer value, right? Now we have the string value, we need to convert it into integer, and there is another function called as stoi. You provide the result into stoi and it returns the integer, and you simply return it, right? So basically there are two functions. One is stoi. What stoi does is that it converts string to integer, and there is another function toString, right? What it does is that it converts integer to string. Now we have this code for the problem that I explained. Now calculating the time and space complexity. The first operation that we see here is we are iterating through the length of the string. Let's say the string is ABCD, then we convert it into 1 2 3 4, right? The length of the string, let's say the length to be n, so this will take an on time. Now getting into here, this is a more complex part where let's say first we had 1 2 3 4, then we converted into 10, and then we converted into 1. If you see, if you follow the pattern, the initial number was n equals to 4, then we had n equals to 2, then we had n equals to 1. If we take a bigger number, we are calculating for the worst time complexity, right? Let's say we had the number to be 9999 12 times. So this is 12 times, right? This is the initial string. So n is 12. Then do you know the next subsequent sum will be 108, right? 12 times 9 is 108. Then the next subsequent will be 9, and we'll stop over here. Now if we see the size of the result, the length of the result is dropping exponentially. So for the worst time complexity, we'll take the initial length to be O12. To be exact, it will be 12 times 3 times 1. But what if the n length is really high? N is very high. If n is very high, the subsequent length of the result string will be very small compared to it. It will be small, and then it will be very small, right? So we can say for the worst time complexity, it will execute for on, and the k value ranges from 0 to 1, 0 to 10, right? Sorry, 1 to 10. And for the k value, now what if for this operation we had, if we ignore the constants in this question to be general, if the k value was very high, let's say 1 million, no matter the k value was 1 million, we will stop this operation after 3 transformations, right? So it will only depend upon the n value, the initial n value that we had. After that, the values will be small, and it will not depend upon the k value for the worst time complexity. So it will again run for on times. So in total, it will run for on squared time. On square will be the general time complexity, and all these functions toString and stoi operates in constant time, right? Now talking about the space complexity, we just only used a result array. We just used a result string which is of the length n. So the space complexity will be on.